This is the third of 3 PowerPoints or videos, depending on which format you're watching, for the topic called carboxylic acids and esters. So just make sure before you continue with this that you have completed the first and second PowerPoint or video. So just to recap, the first one was about properties of carboxylic acids. So in that one, you should have learnt about the water solubility of carboxylic acids in terms of hydrogen bonding. And you should also be able to describe reactions in aqueous conditions of carboxylic acids with metals and bases. You should then have moved on to the second one, which was called esters. And in this PowerPoint or video, you'll have learnt about how to make esters, and we taught you 3 different ways. You can react a carboxylic acid with an alcohol, or an acid anhydride with an alcohol, and also an acyl chloride with an alcohol. So there were 3 ways to make the ester. There's only 2 of those on these learning outcomes here. You'll see why shortly. So make sure that you're definitely secure and confident with how to write balanced equations for each scenario. Once you made the esters, we then taught you how to unmake them by hydrolysis. And the hydrolysis of esters is where we break the bond due to the action of water. And remember, we can do this in 2 different conditions. So it's really important in the exam that you read the question carefully and pick out the catalyst used, because that will influence the products. So we had acid catalyzed and alkaline catalyzed hydrolysis. So with the acid catalyst, you form the carboxylic acid with the alcohol. With the alkali, you form the salt and the alcohol. Really important that you've got that secure. So that's what you should know so far. So make sure that you have checked your progress on those learning outcomes before you continue. And so we're on the third one, and this is all now to do with acyl chloride. So you have met acyl chlorides already in the second PowerPoint, but now we're going to go into a little bit more depth. You need to know how to make them, so the formation of acyl chlorides, and then we're just going to make sure you know how to describe when they react to form esters and carboxylic acids. Okay, we'll look at esterification of phenol as well here. So that's not readily esterified by carboxylic acids, but it can be turned into an ester if you use the acyl chloride. Okay, so click continue when you're ready. So this is the last part now then for Book 2 from Module 6, which is the Organic Chemistry and Analysis module from Year 13. So we're in Book 2, Carboxylic Acids and Esters, and this is Part 3, Acyl Chlorides. In your textbook, we're looking at pages 466 to 469. And as usual, as you work through this topic, please pause for reflection when suggested to process what you're learning. And if you need any help or clarification, do email your tutor or indeed ask questions when you get onto Teams. All right, let's make a start. If you have the booklet, we're back on page 9 now. So you will have completed this part already from the second PowerPoint when we introduced acyl chloride. So just a reminder then, the functional group looks like this. And we make the acyl chloride by reacting a carboxylic acid with thionyl chloride, SOCl2. Now, thionyl chloride is a new reagent for you, so it is one that you're going to have to remember, just like you hopefully now remember things like acidified potassium dichromate, for example. The more you use it, the more familiar it will be, and hopefully it will stick. So thionyl chloride, SOCl2, is the reagent we use to react with carboxylic acids to make the acyl chloride. Now, don't forget, I've mentioned before, the acyl chlorides are quite reactive. They're more reactive than the carboxylic acid. So we've seen them react with the alcohol to make an ester. We don't need to heat up that reaction or introduce a catalyst because it's of that increased reactivity. So they can be very useful. So we're going to look now at how we do form them. So we'll look at the equation with thionyl chloride, and then we'll look at some of the reactions that acyl chlorides will do. Let's complete our box then to summarise the equation. So this is to make an acyl chloride, the formation of acyl chlorides. The reagent then, you need a carboxylic acid and the thionyl chloride, SOCl2, and the conditions are dry. Now for the equation that we've got here, hopefully you can spot a couple of things. So the first thing to look at is the organic reactant and product. Have a look at the functional group, it's changed. So we've gone from a carboxylic acid to an acyl chloride. So the OH here has changed, it's now the Cl. Okay. The chain length is the same, so we haven't increased any carbons at all, and that will be a thing when we look at a few topics in the future. Okay, we'll give you a way of increasing the chain length. So you're always looking for two things when you convert an organic molecule. Have the functional groups changed, so how have they changed, and also check that carbon chain length as well. So we're going from the carboxylic acid to the acyl chloride. Now it is an equation, so it does need to be balanced, and hopefully if you look at that, you might be thinking, it's not balanced, because you've got your sulfur on the left, you've also got two chlorines on the left, so we've got a little bit of work still to do. So I'd like you please to pause the PowerPoint or video, have a think, write that equation out so far, and can you come up with the other products that will be made in this reaction? Once you've got an answer, then you can click play again and see if you were right. Okay, so we started with propanoic acid. Hopefully you got that you would make HCl and SO2. So you might have just pieced those remaining atoms left over together to come up with some familiar compounds that you know, SO2, sulfur dioxide, and HCl, hydrogen chloride. So notice the naming now, you've gone from propanoic acid to propanoyl chloride. Often in the exam they'll ask you to identify organic compounds. It's always a good command word, that identify, because you can choose either to name it or to draw it, and often the safest way is to draw it, remember. And if you think you've got the drawing correct, don't then name it unless you're 100% sure, so that you don't contradict yourself and lose the mark. Okay. So acyl chlorides are named by replacing the oic acid with the oil chloride. So here's a question for you, sometimes gets asked. Why do you think the reaction needs to be done in a fume cupboard? So again, just pause, think, and then click to check your answer. Okay, sulfur dioxide and HCl, because it's hydrogen chloride, it will be a gas at this point. They're both harmful. Now, one of the things that you'll find with this HCl gas, with the reactions that we'll go on to look at, you would actually see those coming off, and we describe that as misty white fumes. Okay, so that's going to be a phrase that you'll see often here. All right, so there you go, formation of an acyl chloride. It's a carboxylic acid derivative, meaning it's made from the carboxylic acid, and we can make it from the carboxylic acid by reacting the acid with the SOCl2. All right, so you need to be able to do balanced equations for any carboxylic acid that they throw at you. Okay, and so make sure that's something that you revise. We're continuing on page 9. We've seen then how to make an acyl chloride. Now we're going to look at what we do with them. So the uses of acyl chlorides now coming up. We're going to summarise first of all the uses for the acyl chlorides. They can be used in the synthesis of esters. First of all, we've already seen that in the second PowerPoint. In the brackets here, really, this is important, including from phenol. So look at that word phenol. Phenol we met in the last PowerPoint. Phenol is an aromatic alcohol. Okay, it's where the OH is directly attached to the benzene ring, so it still ends in ol, to give you that clue, but phenol is the benzene ring with an OH directly attached. Now, to make an ester, remember it's always the alcohol reacting with the carboxylic acid or its derivative. Well, here we could use a phenol instead of the alcohol. However, it won't react with a carboxylic acid, but it will react with an acyl chloride. Okay, so we've got a way here of making an aromatic ester. That's where we're going with that one. Okay, so the second use of acyl chlorides are in the synthesis of carboxylic acids. So you've just seen how we convert a carboxylic acid to an acyl chloride. I'll teach you now how to convert the acyl chloride into the carboxylic acid. Okay. And last but not least, primary and secondary amides. Now, this is one for the biologists, I guess, at this stage. You'll have probably met amides in biology already. We're not going to study this reaction here in this booklet. We do that separately in a different booklet called Synthesis, and that's book 4. So you'll see that then, but we're just going to mention it here. So this isn't something that we'll cover today. Okay, but if you do biology, you might know what an amide is already. Okay, then the main advantages then for using an acyl chloride, well, they're more reactive, and it's not an equilibrium reaction, it goes to completion. So we get a better yield, we don't need a catalyst, and we don't need any heat for the reaction. Let's look at those reactions then. So the reactions of acyl chlorides, the first one was esterification. And if we do our standard esterification with our alcohol, so we react the acyl chloride with the alcohol, the conditions here are room temperature, we don't need heat or catalyst. And if we take the equation ethanol chloride and propan 1-ol. Now this is an equation that I have been through with you before, so I won't pause on this for too long, and I'll just reveal it here and we can talk about it then. Okay, so here's your ethanol chloride and your propan 1-ol. Remember when I write it, normally I would put the functional groups to be close to each other because we need to chop the H off there and chop that Cl off. So I put them next door to each other. So that's made your HCl here, our small molecule. So it's a condensation reaction. Remember, 2 organic molecules coming together to eliminate a small molecule such as water, but in this occasion it's the HCl. So this is really recapping what you've learnt in the second PowerPoint. So notice the arrow goes to completion, there's no equilibrium, and it's at room temperature. So your products then, you've made the ester, and again, just to practice naming, find that oxygen in the chain, and you know that all of this came from the alcohol. So whatever the alcohol was, you need to change that now to an acyl. So instead of propan 1-ol, it's now propyl. And then the remaining part is the ethanoate. So propyl ethanoate for your ester and hydrogen chloride for the other product. Let's stick with esterification. This time though it's with a phenol instead of an alcohol. The reagents then, it's going to be a phenol with an acyl chloride. The carboxylic acid, it's not reactive enough to form an ester with phenols. The room temperature for conditions because that acyl chloride is more reactive, and remember all reactions with acyl chlorides can happen at room temperature and pressure. So we've got ethanol chloride and phenol. So remember what the phenol looks like. There you go, you've got the benzene ring with an OH directly attached to it. So that phenol is instead of the aliphatic alcohol that we've used in the past, but it'll do the same thing. That H will join up with the Cl there to produce your HCl. So the HCl is a small molecule. You would see that as an observation, you'd see misty white fumes. That's a common observation with the previous esterification. And then your ester, then you can see that ester functional group here on the product. Okay, now because this product contains the benzene ring, we can now say that this product here is aromatic. So we've got an aromatic ester. Remember how you name the ester. Okay, so again, you're looking for the oxygen in the chain, and then remembering that this here has come from, well, normally it's the alcohol, in this case it's the phenol, so instead of it being called phenol, it would now be phenyl. So we've got a phenyl ester, and this one specifically will be phenyl ethanoate, and of course your hydrogen chloride there as your second product. Last but not least then, the reaction of the acyl chloride to form the carboxylic acid. So the conditions here, as ever, are room temperature. Now looking at the equation, can you see on the left you've got your ethanoyl chloride, and on the right you've got ethanoic acid. So we're changing it back to its carboxylic acid. And the picture in the corner there showing the reaction happening at room temperature. You can see those misty white fumes again coming out the top. Obviously you're wanting to do that in a fume cupboard really. So just pause and have a think. What do you think the reagent is here? So write out the equation, seeing if you can fill in the gaps. So what would you need to react the acyl chloride with to give you that carboxylic acid and to give you that observation of the misty white fumes? So just pause and have a go, and then press play to check your answers. Okay, so as usual, you play and spot the difference. So we're going here from the Cl to the OH. So we need something that's going to give us an oxygen and a hydrogen, and we also need another hydrogen to make the HCl to give us those misty white fumes. So our second product will be the HCl to match that observation, which means the reactant here is water, H2O. So hopefully you work that out, that the reagent is water. Our products then, it's the carboxylic acid and the hydrogen chloride again. We've come to the end of the topic really now, so I've taught you everything you need to know for acyl chloride. So just pause to check your progress using those learning outcomes on the front cover of your notes. So the first one then, in this section, I can describe the formation of acyl chlorides from carboxylic acids using SOCl2. Then we went on to look at how to use them, so I can describe the use of acyl chlorides in synthesis, in the formation of esters and carboxylic acids. Remember, we're including there the esterification of phenol, which is not readily esterified by carboxylic acids. That's why we need to use the acyl chloride instead, because that's more reactive. Remember, when we say describe, we really want balanced equations showing the structure of the organic reactants and products, so you can see the functional groups changing. And remember, you need to know the conditions of the reaction as well. So the textbook, pages 466 to 469, are good pages to review your learning as well. Make sure all your notes are completed, and then why not do some kind of summary poster to pull everything together, linking your ideas. Then, of course, last but by very no means least, have a go at the practice questions. There are some questions at the end of the booklet that are really good to just check your knowledge and understanding. And you can check your answers against the filled notes, which will be on Connect. Okay, have fun with those. See you soon. Bye.